Hi guys, welcome back. In the introductory video on sequence, I gave geometric progression as one of the examples of sequence. Then I explained that when you have a sequence in which each term is obtained from the preceding term by either multiplying or dividing by a constant factor, then we say such a sequence is a geometric progression, so also known as GP. So in this video, I will be explaining what is geometric progression. With the explanation I just gave on geometric progression, that is when you have a sequence such that when you want to find the relationship between the sequence and you obtain that each term can actually be found by multiplying or dividing the preceding term by a constant factor, then we say such a sequence is a GP. For example, for our usual notation, the one we use when I was explaining arithmetic progression, our first term is A. When your first term is equal to A, and now by the definition of GP, so the next term, if you want to obtain it, we multiply it by the what? By the next, by a constant factor. Let's say we call the constant factor here to be a common ratio. So that is, we have like our common ratio, which is equal to R. So it means if my first term is A, so my second term is what? A multiplied by R. A multiplied by R. So my third term will be what? A multiplied by R. This is the second term, then multiplied by R. So then my fourth term will be A multiplied by R, multiplied by R, multiplied by R, and so on. So in essence, my first term is A, my second term is AR, my third term is AR squared, and my fourth term is what? AR raised power 3. So when you have this kind of sequence, so whereby the preceding term is obtained by multiplying or dividing by what? By a constant term here, which is known as common ratio, then we call it a GP. So if you check the term in the sequence very well, what do you observe? So you will see that my first term is equal to A. So my second term is what? AR. My third term is AR squared. My fourth term is AR raised power 3. What do you observe? So you will see that when I have the fourth term, for example, here I have my the index here on top of the common ratio R to be what? To be 3, which is same thing as 4 minus 1. You understand now? So it means when you have a term, for example, then the number that would be as your index on top of R will be that number minus 1. In essence, if I want to obtain my fifth term here, I don't need to stress myself. That will be AR 5 minus 1. You understand now? So this will give me AR raised power 4. So, okay, what of your 100th term? You can as well obtain your 100th term. Then my 100th term will now be what? AR. Then you subtract 1 from 100. So that's AR raised to power 99. Okay, now what if you want to find your nth term? And don't forget, your nth term is the same thing as last term. Your nth term will be what? AR. So don't forget, you subtract 1 from that number of terms to obtain your index and minus 1. So in essence, your nth term of an GP is giving us AR multiplied by n minus 1. So this is the formula you can use to find any of the term in the GP. So for example, if you want to find 1000th term here, you don't need to stress yourself. Then your 1000 term, this is T1000 is going to be AR 999. You understand now? So, and I've said the other time, your nth term is same thing as what? As the last term. So, where your A here is what? A is the first term in the sequence. Your R is what? The common ratio. And your N is what? The number of term. And N is the number of term. So, if that is clear, let me give you an example to see what I'm explaining. Example, so if I have this type of question, if the question says, let me just make it more bold so that we can see it very well. Just a minute, let me just copy it because of the time. Okay, so the first question here says, find the 10th term, the 52nd term, and nth term of the GP 24816. Yeah. So without more stress, we know from here that this sequence is a GP because if you check the relationship between the terms, you will see that it is obtained by multiplying 2 by the preceding term. For example, my first term here is 2. If you want to get the next term, if you multiply it by 2, so that is what? That is 2 times 2, that will give you 4. So, and if you multiply 4 by 2, you are still going to obtain 8 and so on. So it means my first term here, which is A, is equal to 2. You first of all write the parameter. Then your common ratio, which is the constant term, R. So you obtain that by either dividing the what? The second term by first term, or the third term by second term, or the fourth term by third term, since it's going to give you a constant what? A constant term. That's why we call it a common ratio. So, you know, if you do this, your R is going to be what? Your R is going to give you 2. So, if that is cleared, you know, we know the parameter now, then we can solve the first question here. The first question here asks us to find the 10th term. And don't forget, from the sequence I obtained here, your 10th term T10 will be what? AR 10 minus 1. That is AR raised power 9. So you don't need to stress yourself. So you just subtract, just write AR, then you put your index. What will be in the index is that term minus 1. So it means when you want to find Gavari's term, then it's going to be AR Gavari's minus 1. So when you want to find 1 million terms, that's going to be AR 1 million minus 1. I hope you understand. So, okay, from here, we can just substitute the parameter. That's going to give me 2 multiplied by R. And my R here is also 2 raised to power 9. So, it's also 2 raised to power 9. If you simplify it further, what is 2 raised to power 9? So, okay, if you press your calculator very well, or if you do it by hand, if you can do that, that will give you 512. Then you have 2 multiplied by 512. So, and 512 multiplied by 2 will give me what? So, 1024. Or even here, if you don't want to stress yourself, you can use your laws of indices. This is going to give me 2 raised per 10. You can leave your answer here, or you leave it as 10 raised per 1024, which is 1024. So let me clarify here that when you have, a bigger index, for example, now in the second example I want to do for you, you know, when you have like 2 raised power 50, in fact, some of your calculator cannot give you an exact answer for that, then it suffices to leave your answer, in index form. You understand? So, for example, now the second question asks us to find the 52nd term. That's going to T52. And from the sequence we obtained, your T52 be what? AR raised power 51. How do we obtain 51? Don't forget, if you want to obtain the nth term, so what you are going to do is to write AR first, then on the index, just subtract 1 from the terms you want to find. So in this case, 52. So 52 minus 1 will give you 51. So, and this guy is going to give me my 2 multiplied by r is also 2 raised to power 51. So this is going to give you, when you apply your laws of indices, 2 raised to power 1 plus 51 is equal to 2 raised to power 52. So if you like, you can leave your answer in this form. And if you like, you can press your calculator. But it is advisable when you have a bigger index, you can leave your answer in index form. So our last question, we have to find Tn. Don't forget Tn is ARn minus 1, right? So, and your A is 2 multiplied by, what is your R again? 2n minus 1. You understand now? If you simplify further, since this is a raised power 2 raised power 1, and from the laws of indices, when you have the same base and different index and you want to multiply, just take one of the base and add the index. So that's going to give you 1 plus n minus 1, and this is going to give you 2 raised power n, because 1 minus 1 will be 0. So 2 raised power n. So if you don't know indices, so refer to my video on indices. So I have explained that already. So that's that. You can see it is very simple. Let me still give you another example to back it up so that you understand very well. Example, example. Just let me paste it here. So the third and fifth terms of a geometric progression are 9 divided by 2 and 18 divided by 8 respectively. So in my video on arithmetic progression, I told you whenever you hear the word is in mathematics or are, so it actually means what? Is equal to. So the third term, do it one by one. What is the third term from what we've just said now? Don't forget the third term will be AR raised power what? It is R raised power 2. You just subtract 1 from the term. So that is AR squared. And fifth term will be what? AR raised power H, AR raised power 4. And 9 divided by 2, that is, this one is equal to 9 over 2. And this one is equal to what? It's 1 over 8 respectively. So that's what it's telling you. You can name them. So this can be your equation 1 and equation 2. Then you can find the question asks us to find the common ratio and find the what? And find the first term. So this is not difficult to do. What you are going to do is, when you have this kind of equation, we are interested in finding the value of R and A. So what you can do here is to what? Is to just divide the two equations together. So, and you just simplify further and find the value of your parameter. And since you have two variables, A and R, then we have two equations, then it means we can have a definite result for them. So then if you say divide 2 by 1, you can also divide 1 by 2, but the reason why I said that is that I'm trying to get rid of the negative. So if you divide 1 by 2, so you are going to have the same result as well. You understand now? If I divide 1 by 2 now, it means I'm going to have something like a r squared divided by r raised power 4. You understand now? That will give you a negative index, but if you divide 2 by 1, that will give you a positive index. You understand now? So I just like a positive look, so that, and negative can actually, prone to a mistake, so prone to error. So if you do that, that will be AR raised power 4 divided by AR squared is equal to 9 divided by 2 divided by 81 divided by 8. You understand that? So your A cancel A. So then this will give you R raised power 4 divided by R squared. Then you can rewrite this guy very well. If you change this to multiplication, this is something as A divided by 81. Is that taken? And don't forget from your laws of indices again. So when you have division, and you have the same base and different index, just take one of the index and subtract the power. One of the base and subtract the power. So then this one will give you 4 minus 2. 2 here 1, 2 here 4, 8 here 1, 8 here 9. Then you have 4 divided by 9. Let me write this very well. 4 divided by 9. So that will give you r square is equal to 4 divided by 9. And you have r square is equal to 4 divided by 9. It means what is such a number you are going to multiply by itself 2 times to give you 4 divided by 9. So this same thing as, if I were you can say r squared, or you take the square root, or you can rewrite this as 2 divided by 3 everything squared. So because when you Square 2, when you square 2, you are going to have 4. When you square 3, you are going to have what? 3 as well. So if you equate the index, then your R is something as 2 divided by 3. And alternative way of doing this is to just take the square roots like that. That's what we've done. You understand now? Then you have 2 over 3. So it means your R is equal to what? Your R is equal to 2 over 3, or you can just say plus or minus 2 divided by 3. So from there, you can obtain the value of A. So to obtain the value of A, just substitute R to be 2 over 3 in one of the equation. Put R is equal to 2 over 3 maybe in equation 1. So if you do that, don't forget your equation 1 is what? AR squared is equal to 9 over 2. So whenever you see R now, you put 2 divided by 3. That's A. 2 divided by 3 squared is equal to 9 over 2. So then A will now give you A multiplied by 4 over 9 is equal to 9 over 2. You understand now? So then you can just say 4A divided by, let me write this very well. So 4A divided by 9 is equal to 9 over 2, so that you can do your usual cross multiply. You just multiply through by 9. So if you multiply through by 9, this will give me 4A is equal to 9 over 2 times 9, because now we cancel this guy. So then you have 4A is equal to 81 divided by 2. So if you divide through by 4, then your A will now be 81 over 2. Multiply by what? Multiply by 1 over 4. So which is equal to 81 over 8. So which is equal to 81 divided by 8. I think I've made a mistake. Let's check very well. So when you substitute the value of, did we get 2 over 3 or 3 over 2 here? Let's check very well. Okay. I think we've made a mistake when we are trying to, yeah, so AR raised power 4 is equal to 9. Oh, I made a mistake. This should be 81 over 8 divided by 9 over 2. Sorry, 81 over 8 divided by 9 over 2. So since we are doing it from the denominator, from the second equation, sorry, 9 divided by 2. So, and if you multiply it, this is going to give me 2 over 9. 9 here, 1, 9 here, 9. So it means it is 9 over 4, not 4 over 9. 9 over 4. 9 over 4. Then this is going to give me 3 over 2. 3 divided by 2. 3 divided by 2. 3 divided by 2. So, yeah. And I'm going to have 3 over 2 here. That is 9 divided by 4. That is 9A over 4. You understand now? So then if you multiply through by 4, then this is going to give you again 9A over 4. So, and this is going to be 4. Then 2 here, 1, 2 here, 2. So, 2 here, 1, 2 here, 2. That's it. This will give you 18 now. So, and since this is 9, it means your A will be what? It implies that your A will now be 18 divided by 9. We follow the same process, but when we were dividing, so we actually changed the order. So I'm sorry for that. So in essence, this is how you are going to be doing that. So if you understand, please don't forget to like, share, and subscribe. I will see you in the next video. Thank you.